Okay, number 5. It says a car and a bicycle move towards each other, traveling opposite directions. Each has a speed of 12 meters per second. Mass of the car and its passengers is 1,250 kilograms. And the mass of the bicycle and its rider is 81.6 kilograms. What is the total momentum of the system, assuming that the car moves in the positive direction? Okay, so we've got a car here moving in the positive direction. Okay, mass of 1250, speed of 12.0 meters per second. Then going the other way, we have a bicycle. Proficient in my bicycle drawing ability here, but okay, so we have a bicycle and a car. Bicycle is also going 12.0 meters per second. And very different masses, however. 1,250 kilograms on this side and 81.6 kilograms on this side. Both have their passengers' masses included. Now, they're treating both the car and the bicycle as one system. They want to know the total momentum of the system. Now, P total, which is a vector, is equal to the sum of all the individual momentums. P1 plus P2 for however many momentums there are. In this case, there are just two. There's a car and there's a bicycle. But momentum is a vector quantity, which means direction matters. So they said this one's going in the positive direction, so let's say that that's a positive 12 meters per second, and this one's a negative 12 meters per second. Okay? Now, momentum is still found as mass times velocity. So momentum of the car is going to be mv, so we'll call car the object related link number 1, this whole related link number 2, m1 v1, and the bicycle, we'll call that 2, m2 v2. Just plug in their masses, their velocities, and figure out how much the total momentum is. So 1250 times 12 plus 81.6 times negative 12. So again, their momentums are going in opposite directions. So they are, in fact, taking away from each other. And when we solve that, we should get about 1.40 times 10 to the 4th kilogram meters per second. That's what it is rounded to after we do sig figs. So about 14,000 kilogram meters per second of momentum. Then on number 6, same type of thing, total momentum type problem, except for it's harder. Okay? We're not moving in the same direction anymore. Okay, these were in opposite directions, but not moving in the same dimension anymore. 6 is a two-dimensional problem. So, as we should remember from, I believe it was chapter 4, two-dimensional problems have to be set up differently. So in 6, a 1,200 kilogram car moves due north with a speed of 15 meters per second. An identical car, meaning the same mass, moves east with the same speed. What are the direction and magnitude of the system's total momentum? Again, you have two momentum vectors. We'll call P1 and P2 that are moving at a right angle to each other. Now, in the last example, they're going opposite directions, so we could just subtract them. If they're going the exact same direction, we could just mathematically add them. But we want to know a total. That means to find a sum. But we can't just take the mathematical sum of P1 and P2. We have to find the vector sum. Okay? The vector sum of these two vectors over here. And that would be represented by this vector. Be drawn from the tail of the first to the head of the last. That's P1 plus P2. And again, we're not mathematically adding those. That's just saying the combination of vector P1 and vector P2 is represented by this vector here. And that is what we'll call P total, the total momentum. actually find that value? How do we find the vector value of this? Since one's east and one's north, what can we do? This isn't the worst case scenario where they're not at a right angle to each other, but when they're at a right angle to each other, what math rule can we always use in this situation? Pythagorean theorem, right. Okay? Well, before we do Pythagorean theorem, we have to find out what each of these individual momentums are. M1 V1, M2 V2. Okay? So both have a mass of 1200 and both have a speed of 15. Which means that they have the exact same momentum, just in different directions. The magnitudes of their momentum, their momenta, are 18,000 kilogram meters per second apiece. So, this leg's 18,000, this leg's 18,000. All we got to do is the right triangle, we can find the hypotenuse. So, do Pythagorean theorem, and the magnitude of P total is just going to be the square root of 1800 squared plus 1800 squared. Which, after we do sig figs, comes out to something like 25,000 or 2.5 times 10 to the fourth kilogram meters per second. 2.5 times 10 to the fourth kilogram meters per second. And because the two sides are equal, the direction's easy. If this side is equal to this side in magnitude, that must mean that this angle here has to be 45 degrees. And since one's going east, one's going north, 45 degrees north of east. And that's our final answer. So can't forget all of our vector stuff that we learned a long time ago in chapter 4. This is how we combine vectors. And for momentum vectors, for momentum, this vector stuff is going to be especially important when things actually start colliding and having a before and after type situation. Being able to understand how to do a total momentum, that's going to be really, really important for us.